Hello everyone, welcome back to another session of Verilog coding with me. So let's get started. So today we will be seeing about generate for loop 100-bit binary adder 2. So here is our problem statement. Create a 100-bit binary ripple carry adder. So everyone knows what is ripple carry adder. So let me show you the diagram of ripple carry adder. So this is the ripple carry adder where this will be C in, this will be our inputs, and the carry out generated from the first one will be propagated to the next one, and similarly it goes on until n state. So let's see how we can do it in the code. So here is a hint, you can try it. So we have to use a generate for loop. It is instead of always we have to use a generate. Why we have to use the generate? Because here we are instantiating a single module multiple times. In always block it will not happen. So let's see. So first we have to write a full adder module code. Full adder. So first we have to declare all the inputs and outputs. Input A comma B comma C. C means C. Input S comma C out. So S equal to, in full adder the sum will be A XOR B XOR C. So let's A XOR B XOR C, and C out will be equal to, we have to write the assign statement. And C out equal to, here C out will be A and B, or operation with B, operation B and C, or operation with C and A. So this is our full adder code and module. Full adder code. So we have to instantiate this model multiple times using generate loop. So for generate, we declare integer I. We have to declare the generate variable, that is gen variable I. So we have to this will start from by using generate. As we were writing the always block, here we have to write generate. Now we have to use a for loop for I equal to 0, I less than 99, I plus I equal to I plus 1. We have to write begin, and we have to give our name of the module which we want to instantiate multiple times. So full header, user defined name f1, a of 0, a of I, comma b of I, comma, here output will be seen, it will be a output from the previous C out of previous one. So C out of I minus 1, comma sum of I, comma C out of I. So we have to end the for loop, and we have to end the generate block using end generate. So let's submit the code. So as you can see, compilation process started. So here are the errors. Verilog HDL error, top model B index -1 cannot fall outside the declared range. So as we can see, the error is here. Our model is from our bits start from 0 to 99, and here what we are declaring is that C out is I minus 1, means 0 minus 1, which is not possible. So beforehand we have to declare the model for 0 1 of 0, where a of 0, comma b of 0, comma c of 0 comma C here is C in of 0 comma sum of 0 comma C out of 0. So here we have to start the loop from 1, because here it will be 1 minus 1, it will be 0. So let's submit the code. So as you can see, compilation process has been started. Again there is a error, can't index object Cin with 0 packed or unpacked array dimensions. Okay, so we have to write just Cin, as here we have not mentioned any bits, it will be a single bit. So here the warnings, we can ignore it. As you can see, the status is incorrect and there are few mismatches in our diagram. So let's see how we can debug it. So here instead of 1 and A, our set is coming 1 and 2. So let's see how we can debug it. So what is error? Here we can see we are starting from 1 and ending before 99, means we are not including 99. So we are missing our 1 bit. So instead of 99, we have to make it 100. So let's submit the code once again. The compilation process has been started. There are no warnings. So as you can see, the status is success. And here ends our problem. That's all for today. In the next video, we will be seeing about BCD add 100.